Finishing up the section on hyperbolas, up at the top of the page we see a chart that just tells us everything about what we need to know about hyperbolas that are not centered at the origin. And just like with the section on ellipses, I think it's easier to see and understand what all this information means in a diagram. So we have our two equations that are the same as they were when the center is at the origin. So just here we're looking at our h and k values being subtracted from x and y. All right, so now our vertex is going to be at h and k instead of 0, 0. So if the transverse axis is parallel to the x-axis, our x term has to go first. If the transverse axis is parallel to the y-axis, our y term of the equation has to go first. So just looking at the example that we have here, it's a little easier to identify everything here. We have a center at the point 1, -2, a focus at 4, -2, and a vertex at 3, -2. So we always want to graph our information. This will give us a visual of what we're looking at. Center at 1, -2, so here's our center. A focus at 4, -2, and a vertex at 3, -2. So we can see that our transverse axis is parallel to the x-axis. So that means the x part of our equation is going to go first. So we're going to have, and if we remember our h and k values being at 1, -2, we're going to have x minus h, which is 1, squared, minus y minus -2, minus -2 is y plus 2 squared. And this is going to be over our a squared and b squared values. And again, this is set equal to 1. So we can determine our a and c values from this. From our center, let's label our other vertex and focal point. So I know that my vertex is 2 units away from the center. So that means our a value is 2. A is 2. So I'm going to go 2 units in the other direction, and here is another vertex. And my focus point is 3 units away from the center. So my C value is going to be 3. And I'm going to have 1, 2, 3 units in the other direction. So here are the 5 key points. So I know that under the x term in the equation, I'm going to have a squared, so that's going to be 4. And to find out what b squared is, I'm going to use the formula a squared plus b squared equals c squared. A squared I know is 4. C squared is going to be 3 squared, which is 9. So this number in here for b squared is going to be 5. So b squared is 5. That means b is the square root of 5. So I just need this to measure where I'm going to put those vertices that aren't part of the graph to help us draw our box so that we can get our diagonal asymptotes. So this is about 2.2-ish, 2.2, 2.3, a little bit more than 2. So from the center, I'm going to go up 2 units, and there's your other vertex right there. And then I'm going to go down a little bit more than 2 units, and there's another vertex. And if I were to draw my box around these vertices, I can draw my asymptotes going through the diagonal corners and through the center. And from my vertices, I can draw on the branches that will approach those asymptotes. And instead of writing the equation of the line for these asymptotes, what I'm going to do is I'm just going to write the slope. Because we're not going through the origin, the main thing here is we really need the slope. So from my center, I'm going up 2 and a little bit more. That was the square root of 5. So my slope for this line is the square root of 5, and I'm going over 2. Square root of 5 over 2. This one is the same thing, but it's negative because my line is going down. I'm going up the square root of 5 and over 2. Okay, but it's a negative slope there. So I think we have everything that we need here. We have the equation, and we did graph the equation. So looking at one more example, we have an equation that's written not in the form that we can identify the center. So we're going to rearrange our pieces. And as I look at the x squared and y squared terms, I notice that x squared is negative and the y squared term is positive. So I'm going to use the y's first. So I'm going to have 4y squared. And I'm going to put the other y term with this, minus 16. My x squared terms, I'll have a minus x squared and a minus 2x. And I'm going to send the 11 to the other side, and that would be minus 11. So to find the square of the binomial, so we can find our h and k values, I need to complete the squares for both my x squared and y squared terms. So because I have a coefficient of 4, I want to factor that out. And I'll have y squared, whoops, this was minus 16y, so this would be minus 4y, plus some number that will allow us to complete the square. So half of negative 4 is negative 2. If I square it, I get 4. But when I add 4 here, this 4 is going to be multiplied by 4, so I really added 16 to this side. So then over here I have this minus, and I want to keep the minus out here. So I'm going to have x squared, and this is kind of like factoring out the negative. So if I factor this negative out, I'm going to have negative, and I'm going to have plus 2x here because a minus and a plus would be a minus. And then leave the space to complete the square. Half of the middle term is 1. 1 squared is 1. So really what I did here, because I have this minus here, is I'm actually subtracting 1. This 1 is being multiplied by this minus. So I'm going to subtract 1 here. So if I factor my perfect square trinomials, I'm going to have 4 and then a y minus 2 squared, and I have minus x plus 1 quantity squared, and this is going to equal 5 minus 1 is 4. So because it doesn't equal 1 here, we'll divide all of our parts by 4. So the 4's cancel here. I'll have y minus 2 squared over 1 minus x plus 1 squared over 4. Nothing can cancel here. And this equals 1. So this is my equation. So if I graph what I have here, I know that the center of this hyperbola is going to come from my h and k values. So my center, my h value is always with k in the parentheses, so it actually comes in the second term here. So the number subtracted from x is -1, and the number subtracted from y is 2. My center is -1, +2. And I know that this is a squared, so a is going to equal 1. This is my b squared value, so b is going to equal 2. And the 1 is going to go up and down from the y value. It's going to be a tall or my transverse axis is going to be parallel to the y-axis. So this tells me I'm going to go up and down 1. So up 1 and down 1. And these are my vertices. Here's my center. If I label these, my center is -1, 2. My vertices are -1, 3 and -1, 1. And my foci are going to come from the equation a squared plus b squared equals c squared. So a squared is 1. B squared is 4, so c squared is going to be 5. So my c value is going to be the square root of 5. And I'm only going to use this as a measurement, so I'm going to say that this equals approximately, what did we say before, 2.2? So from my center, I'm going to go up 2.2. So here's a focal point right here. Going down 1, 2. Here's a focal point right here. And my b value is 2. So this is going to tell us on the non-transverse axis, not a part of the graph, I'm going to go 2 units. So over 1, 2. And 1, 2 here. So if I make my box there's my box, the C right in the middle, and I'll make my horizontal asymptotes or diagonal asymptotes right through here. And from my vertice on the transverse axis, I'm going to draw the branches of the hyperbola. And it's going to look like that. And the very last thing that we need to do is we need to find the slope of these diagonals. So from my center, I'm going up 1 over 2. So my slope of this one is +1/2. This line is negative, it's going down. My slope is -1/2. And that should be it. Okay,